In this lesson, we talk about equations involving absolute value. Now, from earlier in our math discussions, we know that absolute value is defined as the distance a number is from zero. So if we look at these two examples and we ask what's the absolute value of 8, that's 8 units away from zero. So that's equal to 8. Negative 12 is 12 units away from zero. Answer 12. If I want to solve this, and I say, what number in absolute value is 7 units away from 0? Alright, that's what this says. Then I can look at a number line where here's 0, here's 7, which is 7 away from 0, but I also know that negative 7 is 7 units away from 0. So this absolute value really is equivalent to some positive and negative number. Alright? If I say, what number is negative 10 units away from 0, well, a negative distance makes no sense. We say there's no solution here. So one more time. While in this first example, we can say that positive and negative 7 is 7 units away from 0, we can't say there is a negative distance away from 0. When I say, what value is W away from 0, well, I don't care what W is. It could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, but their negatives or their opposites are also the same distance away from 0. So this answer would be plus or minus W. When we want to solve an equation, we can't do any kind of mathematics with this stuff inside an absolute value. So what we have to do is remove this quantity from the absolute value. Now, we found earlier that the absolute value of anything is equal to plus or minus that anything value, right? So basically what we've got is if we want to remove this term from inside the absolute value, we say, well, plus or minus whatever that stuff is equal to 3. Now I've got a parentheses rather than an absolute value, but I also have two equations, one in a positive sense, one in a negative sense. So I have x minus 14 equals 3, and I have the opposite of x minus 14 equals 3. Now you can solve this any way you want. As far as this side goes, this side we're just going to add 14 to both sides. We get 17 as one of our answers. And in this case, I'm going to multiply by negative 1 to both sides, or divide by negative 1. So in this case, I get x minus 14 equals negative 3. Add 14 again to both sides, and I have 11. So when I go to answer this problem and put my values on a number line, I say at 11, I have one value, 17, I have another value. If we look at this example, I have an absolute value of something equaling a negative number. Right here, I can stop because I know there's no number whose absolute value is equivalent to a negative number. So right here, I just say there's no solution. In this next example, it's a little bit different in that I have some extra item tacked on to the absolute value problem. First thing we want to do on all of these is isolate the absolute value. So in order to do that, I subtract 6 from both sides, and I can do that because it's not within the absolute value. So I have the absolute value of 9 minus 2x equal to 27. And now I want to pull this from the absolute value. So again, I say, well, plus or minus 9 minus 2x is equal to 27. So my two equations are 9 minus 2x is equal to 27. and negative 9 minus 2x is equal to 27. Next, we take and solve each of these two equations. I'll solve this guy by subtracting 9 from both sides, which gives me 18 is equal to negative 2x. Divide by negative 2 to both sides. Negative 9 is equal to x. And on this side, I'll divide by negative 1 to both sides, giving me a negative 27 equals 9 minus 2x. Subtract 9, giving me a negative 36 is equal to negative 2x. Divide by negative 2, and I have x equals positive 18. So if I write this on a number line, so I'm going a little crooked here, I get a negative 9 and a positive 18. Again, a very similar example, except once again, the 16 is added on to the absolute value. I also have this multiplication of 2. And if I want to split this up into two equations, I have to isolate the absolute value first. So subtract 16 from both sides. Get 34 is equal to 2 times 3 minus x in absolute value. Divide both sides by 2. 17 is equal to the absolute value of 3 minus x. Oops. Like so. I want to pull this out of absolute value, so I hit the plus or minus of the quantity 3 minus x equals 17. I'm going to roll this over to here. So I have two equations now. 3 minus x equals 17, and I have opposite of 3 minus x equals 17. Subtract 3 to both sides. Negative x equals 14. Divide by negative 1. X equals negative 13. Likewise, on this side, I divide by negative 1 first, giving me negative 17 is equal to 3 minus x. Subtract 3. Equals negative 20. Divide by negative 1 equals 20. So I have negative 13, positive 20 on my number line. So now we've got word problem. It says this person uses an elliptical trainer. The goal is to burn 280 calories per workout, but it can vary as much as 25 calories on any given day. And we want to write and solve an equation to find the maximum and the minimum value that the person burns. Well, this is pretty easy to just kind of figure out what are the maximum and minimum amount of calories. If I'm going to have 280, and it can vary as much as 25, I could be higher by 25, or I could be lower by 25. And that's going to equal my unknown value. Now, I can get my answers no problem, because I just add 25 to 280, giving me a total of 305, or I subtract 25 from 280, giving me 255. Those are my two answers, but I haven't really written an equation to solve this in absolute value form. So I'm going to go ahead and do that now. So if I have plus and minus, that means I got that from doing some kind of a absolute value calculation. So if I'm going to add plus or minus to something, I need to then remove this number and add an absolute value. So I bring the 280 over to the other side, and that equals plus or minus 25. We said absolute value is equivalent to a positive or negative distance. So what I'm going to do is tack on my absolute value sign to the x minus 280 and set that equal to 25. Notice the plus or minus goes away. Special words for some of this stuff. When you're writing an absolute value equation, the middle, or what we call central value, is always placed inside of the absolute value. So this guy, the 280, is our central value. All right, and 25 acts as can go higher than or lower than 25. So this acts as our range. And that's the guy that goes outside of, or on the other side of the quality side. Got a couple more. This problem is a little bit more difficult because you'll notice here that I have an absolute value that's already isolated, but the term on the other side also has a variable in it. We still handle the problem the same way. The absolute value has been isolated, so now we give it the plus or minus to remove the absolute value sign. And we just handle it like we would any other equation in one variable with two variable terms on either side. We say we've got 4x plus 3 equals 15 minus 2x. That's one equation. And then we have our opposite of 4x plus 3 equals 15 minus 2x. So let's deal with the problem on the left-hand side first. We add 2x to both sides and subtract 3 to both sides, giving me a 6x and a 12, dividing by 6 to both sides gives me x equals 2. In this case, I can do it a number of different ways. I could divide by -1 to both sides, or this time I'll take and distribute the negative in. So I have a negative 4x minus 3 is equal to 15 minus 2x. This time I think I'll add 4x to both sides and subtract 15 to both sides. This side yields negative 18, while this side gives me a positive 2x. Divided by 2. So I get values of 2 and negative 9. And you could pop those in and check just to verify what you've got going on. If I put a 2 in here and a 2 in here, I get 8, 11, and 15 minus 4 equals 11, so that checks. If I plug negative 9 in here and negative 9 in here, I get negative 36 plus 3, which is negative 33. So it gives me a positive 33 in absolute value. And then I have a 15 plus 18, which is 33, and that checks as well. So in this case, very similar problem, except the side on the right has the 2 linked up with the absolute value. We want to isolate that absolute value first, so I'm going to divide both sides by 2. Or I could multiply by a half, which I like doing a little bit better, only because some people, when they divide this term by 2, only divide the 40 by 2. So we'll just go ahead and do that. We get a 20, and 2x is equal to the absolute value of 3x minus 10. Again, hit our plus and minus case. 20 minus 2x equals plus or minus 3x minus 10. So 20 minus 2x equals 3x minus 10. And 20 minus 2x equals the opposite of 3x minus 10. Deal with the left side first. Add 2x. Add 10. 30 is equal to 5x. X equals 6. In this case, 20 minus 2x equals negative 3x plus 10. Add 3x. Subtract 20. End up with x equals negative 10. So the whole key is isolating the absolute value sign, then creating a plus minus equation once we remove the absolute value, and solve the equation as you would any equation in a single variable. That's all we've got. Make sure you do the assigned problems in lesson 3 and fill out your lesson summary. See you tomorrow.